Hello viewers, welcome to Add-on. In this question, we are gonna explain how a zener diode can be used as a voltage regulator. Okay, so let us start. So the zener diode, the symbol of a zener diode is like this. So this is the schematic symbol of a zener diode. It is basically made up of a PN junction. Okay, so this is a silicon semiconductor or a PN junction that is specifically designed to work in a reverse biased ND. So we know the PN junction can be biased in two ways. One is forward bias and one is reverse biased. So the Zener diode is a PN junction device which is specifically working in a reverse bias condition. Okay. But the thing is, can't we use Zener diode in forward bias? The question is yes, but the thing is, the main objective of using this zener diode is satisfied when we are using the PN junction in reverse bias. When we are using the PN junction in forward bias, the zener diode will act as a normal diode. So there will be no differentiation between the PN junction, ordinary PN junction, and zener diode. But when the PN junction is reverse biased, then we can use zener diode for many applications. So after that, we can easily differentiate between a PN junction and a zener diode. Okay. So what happens is zener diode is that when forward bias, it acts like a normal diode. But when reverse bias voltage is applied to it, the voltage remains constant for a wide range of current. Okay. Because when a PN junction, suppose this, when this is forward bias, what happens? The depletion region decreases. So electrons will pass on to the P side. Okay, electrons from N side will pass on to the P side and the holes from P side will pass on to the N side. Okay, so current flow will occur. But during reverse biased, what happens during reverse biased? During reverse bias, the depletion region or the width of the depletion region increases. So the electrons or holes cannot grow or cannot transmit from one region to another region. For example, electrons from N region cannot transmit to the P region, or holes from the P region cannot transmit to the N region. Okay. So what happens? Suppose for -1 volt, the amount of the current we are getting for -2 volt, the amount of the current will be same. Same for -3, -4, -5, like this. Okay. So due to this specific function, that even when we are increasing the reverse biased voltage, the amount of the current we are getting at the output is same. Due to this particular function, zener diode is known as a voltage regulator. Okay. But the thing is, I am saying here that for -1 volt, the current we are getting is same for -2, -3, -4, -5. But it is not like the case that even if we increase the current after it -6, -7, -8, the current will remain the same. Because the Zener diode has a particular voltage level which is known as the breakdown voltage. Typically, it is around the range of 5 volts. That's the reason why I have written up to -5 in this scenario. Because after reaching this breakdown voltage, if we further increase the reverse bias, the diode will enter into a breakdown region, or the potential barrier between the N and P region will break down. Okay. So after that time, rapid number of electrons will flow from N side to the P side. So the amount of the current after reaching the breakdown voltage will become very high, and during that time, when the zener diode enters into a breakdown region, the amount of the current becomes so high that the diode becomes infunctional or dysfunctional, or it may burn out. Okay. So this 5 volt, this is the zener breakdown voltage. So why are we using this zener diode as a voltage regulator? The voltage regulator is specifically a device that regulates the voltage level. It essentially steps down the input voltage to a desired level and keeps it at the same level during the supply. Okay. So this ensures that even when a load is applied, the voltage doesn't drop. Okay. So they are particularly used for two main reasons. First main reason is to regulate the output voltage. Output voltage regulation. Okay. So this is the first job of a voltage regulator, to regulate the output voltage. And the second job is to keep the output voltage constant at desired value, even when the input voltage is varying. Suppose the current we are getting at minus 4 volt is our desired output voltage. So if we increase the reverse bias voltage at the supply, the voltage regulator ensures that the output voltage should always remain at a minus 4 volt. Okay. So it will keep the output voltage constant at that desired value even when the input supply voltage is varying. Now we will draw the circuit diagram of a zener diode as a voltage regulator. Okay. Okay. So this is a circuit diagram of a zener diode as a voltage regulator. So how does this circuit works? I'm gonna explain it. So we can see there is a series resistor which is connected to the circuit in order to limit the current into the diode. So this is the series resistor which is connected to the circuit. It is used to limit the current entering into the diode. It is connected to the positive terminal of DC. This is VL. This is the positive and negative terminal. Okay. Suppose the positive terminal is applied in this node and the negative terminal is applied in this node. So this R is or the source resistance. It is connected to the positive terminal of the DC. And it works in such a way that the reverse biased can also work in the breakdown condition. Okay. And we need to know that this zener diode, as I have said earlier, this has a particular breakdown voltage. So we do not use ordinary junction diode because low power rating diode or the diodes which have a low rating can get easily damaged when we apply reverse bias above its breakdown voltage. Because after reaching the breakdown voltage, then the current in the device will increase, we can say exponentially. So for a low rated diode, the diode may burnt out or the circuit may get damaged. Okay. Since the input voltage and the required output voltage, the input voltage, this is this, and the required output voltage is known, it is easier to choose a zener diode with a voltage approximately which is equal to Vz equals to Vl. Okay. So the value of the series resistor, which is Rs, this is equals to VL minus Vz divided by IL. Because if we look at this node, if we apply the law of KCL here, the amount of the current flowing is this is source resistance Rs and this is the input voltage VL. So VL by Rs minus Vz by Rs. So Rs will be equal to VL minus Vz divided by IL. Okay. So the current through the diode will increase when the voltage across the diodes tends to increase, which result in the voltage drop across the resistor. Similarly, the current through the diode will decrease when the voltage across the diode tends to decrease. Hence, the voltage drop across the resistor is very less and the output voltage results normally. Okay. So what I have said, the current through the diode will increase when the voltage across the diode tends to increase. The voltage across the diode means this voltage, positive, negative, this voltage. If this voltage tends to increase, like this voltage VL, if this voltage increase, okay, the current through the diode will also increase, okay. And as this is the more positive quantity, the voltage drop will increase gradually. But if the voltage across the diode is decreased, then what happens? If this voltage is decreased, the value of IL or the current through the diode will also decrease. And as it decreases, it will reach a more negative value or more, we can say more lesser sided value or less value than the value which we are getting when the value of VL was increasing. So in this scenario, when the value of VL is decreasing, this quantity VL by RS, this will also decrease, and this is already in negative sign, means it is already decreasing. So overall voltage drop will decrease and the value of current will also considerably decrease. Okay. So this is all about zener diode. And one thing we should know, that this zener diode that we are using here typically operates at the breakdown voltage of 5 volt, but it is not mandatory that this will operate at 5 volt only. Several zener diode have breakdown voltage which are not equal to 5 volt. They may be lesser, or they may be, we can say, they also may have a high rating. Okay. So the typical objectives of it are these two: output voltage regulation and keeping the output voltage constant at the desired value. Okay. And one thing we need to make sure that, suppose in this case, this is the fluctuating DC. If this voltage suppose is varying from 1 volt to 10 volt, okay, and this zener diode has a break, and if this zener diode has a breakdown voltage of 5 volt, okay, suppose this zener diode has a breakdown voltage of 5 volt, so at the output, it will limit the breakdown voltage, or we can say the breakdown voltage is 5 volt. So it will limit the input voltage to 5 volt only. Okay. So the VI characteristic curve is like this. This is the particular breakdown voltage. We can see up to this point of curve, the curve is almost constant, or we can say when we are reducing the reverse bias voltage, suppose from say 0 volt to -1 to -2, the current is almost remaining constant. But after attaining the breakdown voltage, the current is increasing exponentially. Okay. So what happens in a zener diode is that, suppose we are fluctuating the input voltage from 1 volt to 10 volt, and the zener breakdown voltage is 5 volt. So if we fix the DC supply at 3 volt, okay, then we will get 3 volt at the output. It will be of no issue. But suppose if we are putting 8 volt in the input, then the zener diode will produce 5 volt at the output. It will not produce 8 volt, because after 5 volt, the current will increase exponentially and it will attain the breakdown region. So even if we apply 8 volt or 10 volt or 12 volts, the output voltage will be 5 volt. So this is the one of the most important application of the zener diode as a voltage regulator, because even if we increase the supply voltage, the output voltage, it will remains the same. Okay. So the input voltage is varies from 0 volt to any value to 15 volts, 1, 2, 3, 4, 5, 6, from any value, the output voltage will remain the same. It can exceed this breakdown voltage. Okay. It cannot exceed this breakdown voltage. The zener diode always limit the input voltage to 5 volt. So this is all for zener diode as a voltage regulator. Thank you.